G'day, Glenn Morris here from the Smart Energy Lab, and today I'm going to look at this Sharp panel behind me. Now, Sharp, you probably know them for their consumer electronics, but what you might not know is they're actually been making solar modules for, let me check, since 1963. They made solar cells back in 1963, and their PV cells were used in space as early as 1970. You've got a company that's been in business for over 111 years. That's pretty amazing. In terms of a technology company, it is one of the oldest. So what are some of the high points of Sharp? Well, the panels behind me here have a really high conversion efficiency, at a panel level over 21.5%. But on top of that, you've got a panel with a 25-year warranty. That's product warranty, as well as a linear performance warranty. Now, everyone can say, my panel has a 25-year warranty, but how many companies can you trust will still be in business in 25 years? A company that's been around for 111 years is diversified like Sharp into a whole range of consumer electronics and technology products is going to be around to stay. So let's look at some of the other achievements of Sharp. So they produced a tandem silicon stacked solar cell module that achieved the world's highest conversion efficiency of 33.66% in October 2023. Now, what is a tandem stack? That basically means that you've got multiple junctions within the same cell, and that gives kind of like having two bites of the solar cherry, and they get more performance out of that small footprint of the panel. The panels have been through some pretty severe testing, including something called the Salt Mist Test Severity 6. So these panels are suitable putting in harsh environments near ocean spray, etc. Sharp has completed over 750 megawatts of installation with a 50 megawatt scale EPC solar project in Vietnam recently, 1.3 gigawatts of solar power plant at the EPC project in Japan, and one solar plant of 111 megawatts. Wow, that's pretty impressive. So a total of 17.1 gigawatts of Sharp solar panels have been installed globally. Now, this panel behind me, let me tell you a little bit about it. I've got the data sheet here, and let's bring it up. So this is their TOPCon half-cut cell system. The panel is the NUJC420B, and it's N-type TOPCon. This particular panel is 420 watts. Some of the things that are pretty important to note are the performance warranty. So it's a positive plus 5% guarantee. That means you'll always get 420 watts, but you might get up to 5% more, just depending on the manufacturing variation. These have been tested to the required tests, the IEC 62615 and 61730 Fire Class C, which means they're suitable for rooftop installations in Australia under our PV array standard. As I mentioned before, N-type TOPCon, 21.51% module efficiency. So you're getting a lot out of that small footprint. And the half-cut cell technology gives you a lot of shade tolerance because effectively you've got sub-modules within a module that work independently when there is partial shade. So that's a really nice outcome. So once again, 25-year linear performance warranty and 25-year product warranty. These panels are going to be around for a long time. The ISC of this panel is 13.86 amps. Now, it's important with respect to our PV array standard to be aware that that ISC value needs to be multiplied by a factor of 1.25 when selecting cable, overcurrent protection devices, isolation devices, and the PCE input rating for short circuit. All of those. So let me just do a quick calculation. What the minimum ISC, for instance, of your inverter would need to be. So these are 13.86 and multiply that by 1.25. So as long as the inverter has a short circuit input rating of 17.3 or greater, then these modules are suitable for that inverter. So that's pretty cool. The IMP is 12.99 and we've got a VOC of 38.63. Now, those low VOCs are good because it means you can run longer strings. So if we're looking at a VOC of 38.63, and here's a hot tip, I reckon this year 5033 and 4777 Part 1 will align on the 1000 volt for residential installation of PV systems. So if you can go up to 1000 volts on a residential PV system, you take the VOC, which is 38.63. Now, we can just use one of those factors in table 4.1, I think it is in 5033, that gives you a multiplying factor based on your coldest operating temperature. So let's use a fairly typical figure for Southern Australia of 1.12 times. And let's see, we get a VOC adjusted for cold temperature of 43.26 volts. Now, remember that number, 43.26. Now, if I've got a 1000 volt maximum array and I can go up to 43.26 per panel, that means I can put 23 panels in a string. Whoa, 23. So 23 times 420 watts, that's 9.66 kilowatts in one string. Now, this is becoming a thing because Australians want bigger systems, and often inverters only have 2 MPPTs. So to be able to get as much power onto 1 MPPT as possible, given that your inverters are capable of running up to that sort of voltage, is a big plus. So in summary, this module with a relatively low VOC maximum and a comfortable ISC is very suitable for the type of inverters we have at the moment on the Australian and New Zealand market. So in summary, I'm pretty excited. This is the first time I've actually seen a Sharp panel in many, many years, and Sharp is making a move back into the Australian market. So welcome back, Sharp. Thanks for watching.